24 days, a radioactive isotope decreases in mass from 64 grams to 2 grams. What is the half-life of the radioactive material? Now, look at this question here. That 24 days means time taken for the radioactive element to disintegrate, that is, to decay. So call that small letter t, which is 24 days. A radioactive isotope decrease in mass, initial count rate, we call that N1, 64 grams, to what is left now is called the final count rate, N2, which is 2 grams. What is the half-life? Half-life is capital letter T, which is question. But here now, half-life T is small letter t over log of r to base 2. R here represents the disintegrating ratio. R equals to disintegrating ratio, and R is given as N1 divided by N2. N1 is 64, N2 is 2. This divided by this, we are going to have 32. Put this back into this formula now. So we have T equals to, small t is 24, 24 over log of 32 to base 2. And that will give T equals 32 here is same thing as 2 raised to power 5 to base 2. And according to power law, in logarithm, we move this 5 behind the log. You have 24 over 5 log 2 base 2. Here, logarithm of a number to the same base, 1. So we'll be left with t equals to 24 over 5. And that will give 24 divided by 5, 4.8 days. That is the time taken for the half-life of the radioactive material is 24 days. The half-life of a radioactive material is 6 hours. Start with that. Half-life is 6 hours, capital letter T, 6 hours. What quantity of 1 kg, that is the initial mass present N1, is 1 of the material would decay in 24 hours. 24 hours is time taken for the radioactive material to decay, small t, 24 hours. What quantity, that is number of atom that has decayed, Nd, is the question. So Nd is N1 in the bracket of R minus 1 over R. But looking at this now, R is not given in this question. Disintegrating ratio is T over big T. And you have R to be T here is 24. Then the big T is 6 hours. This and this will give 4. Put that back to this formula. Nd will be N1 is 1 in bracket of R is, just cut it,